In the couple of videos previous to this one, we went through and deployed a runner fleet. This is the fleet of runners, and we talked about how they have sort of a pool level identifier. So if we look at the tags here, the first part of the tag before the underbar is the pool identifier, and the second half is the individual unique runner value. Now what we're going to do is create a project that takes advantage of this pool. So I'm going to go to the embedded level. When I go back to the CIC catalog and I look at the device cloud component, at the bottom, it says working example code using this component. And I try to do this for all the components I build, but basically there's a working example here. In this project is a CI YAML setup that is going to help me show you how this works. So I'm going to go to my embedded project and I'm just going to call my new project. Let's see here. We'll create a blank project. We'll call it brakes controller. So I'm going to say edit and just use the web IDE right here in GitLab. We'll start by going in and simply creating a GitLab CI YAML in here. So I'm going to type GitLab CI YAML. And if we go back to our component tells us how to use it. Now, I give you these examples here in order so you can see how things need to be done. But the version here is left up in the air. And the latest version here is 0.1.100. If you go to here, you can actually copy the include code, but it doesn't have any of the additional code. So I'm going to initially copy this include, so I peg to the right version. You always want to peg to a version and not to latest. Automation deserves the same stability as regular software that we work with. And if you don't peg it to a specific version, then when you deploy to production, you're not actually pegging to something that's known to work. So I'm also going to grab the variables here, and we might switch it up with the variables a little bit. So we're going to go in and paste into here. Now it says here, token set up as a CI variable. So we don't really want tokens in source code. And so when it says set up as a CI variable, it's talking about back in our project variables. So now we need to create the token in a place where our project can inherit it. And I'm going to pretend that all projects under embedded will always use this exact device cloud. And we'll go ahead and create it at the group level. If this wasn't true, then we could create them at the project levels. So I'm going to go in here, do CI/CD, variables. It says it has to be called exactly this. So we'll do add variable. We want to set it to masked because it's a token. We want to uncheck protected. Protected does not mean you're not allowed to change this variable. It has to do with some fairly elaborate GitLab features that have protected branches and protected runners. This will be the key name. And then we're going to go to our script here where we have a copy of the variable stored, and we're going to grab a copy. All right, put this token in here. As with all these videos, the tokens that you see on the screen have already been deleted by the time the video is uploaded. And then the other setting that we need is the project pool ID. Now, I show it as being set here, but I think what we'll actually do is set it at this level as well. And then that way, all these projects will inherit the exact same pool, and you'll see how it's even easier. So here's the key name. We need the pool project ID. I'll open a new window here. Here's my project. And for project and group IDs, we go to Settings General, and we get them right here. And we'll drop it in right here. Add that variable. So now we have, I'm going to cancel this. We have both of these values flowing down into all the projects under embedded. And so in our IDE here, we don't even really need these guys. So just the include. And then if you remember from when we were reading in here, it says if we have a pipeline named this, it will process it. So let's go ahead and create a file by that name. And the contents, I'm actually going to copy out of the working project we mentioned, and I'll explain them a bit. So this is my hardware in the loop pipeline, and basically it is basically running as a child pipeline. So what's going to happen is the code inside the component will start a pipeline, allocate a runner, and then run this pipeline. And this pipeline is really simple. It's just saying hello world from each of the stages. Notice here, though, it's also got a non-hill job. So even though we're inside of a pipeline that's allocated to a hill, as long as we don't use the runner tag right here, this job doesn't have it, then it will run back out on whatever the default cloud runner is or whatever runner I want to schedule it to go to. So keep that in mind too. You can have non-hill jobs running inside of a hill allocation. Now, to really understand how this all works together, we're going to have to take a quick peek at the actual code of the component. So whenever you want to see the code of a component, right here, this is hyperlinked. This is actually the path to it inside of the GitLab instance you're on. And then I'm going to click it. And when I go to the source of the component under templates, I'm going to click this, and it shows us what's going on, what happens. So there's an allocate function or routine. The dot in front of it means don't run it now. I'm going to use it later. And then we do a hill allocate. We extend that job that we just looked at, and then it basically says only run this if we find that file that we just created. Then it also does a child pipeline using that file. And so a child pipeline then allows us to set the runner tag for everything in the child pipeline. Since runner tags are set when pipelines are processed by GitLab, we have to call a child pipeline so we can force it to that tag. I should also note that when we built the runner, we said only to ever run one job on it. So even when we use containers, it's just going to run one container at a time and have access to the hardware that's on that particular device. And then here's the deallocate routine. I'm not going to go through the code in here, but basically all it's doing is going and getting that variable and writing to it. I will mention one special thing is the way we're managing contention. So what if two projects try to grab the same variable at the exact same time? What we do is we basically go grab it, and then we write to it, and then we read back. And so in the case where two write at the same time, then they'll end up, one of them will win, and whatever one reads it back and it's the same value, says, hey, I got it, and it goes with it. And then the other one, this is a loop, it will loop around and try again. And if it can't find any, then it's going to stay in the loop, and it'll tell you in the log, hey, I'm looping, trying to get a runner allocated, or a hill runner specifically allocation. All right, so we'll go into our IDE here. So this very simple include is going to trigger all that enclosing functionality, and we only have to be focused on our pipeline here. And this is my commit, run my hill pipeline, commit to main, and we're going to go ahead and just commit it to main. We're not going to work with branches today. I'm going to go find my project, and we get to see whether we did everything right or something needs fixing. So we go to build pipelines. The pipeline is started. It's doing the allocate procedure. I'm going to also bring up the device cloud variables. Okay, no, we're not there. Right here. And if I expand variables and say reveal values, look at this. In use by, this is the pipeline ID, and then it's got a sort of date timestamp so that we can do maintenance and figure out if something's stuck, what pipeline's supposedly running it. So there's some details in here that might help for long-term management maintenance. Go back to our pipeline and refresh. We can see it started the child pipeline. I'm going to open that child pipeline, and we can see that it's run a couple of the jobs. I'm going to open one of them, and you can see here that it's on this particular tag, and it has run Hello World 1. It did it with Docker, so you can, the details here, you can see that it's loading a container and running that Docker image, but that we're okay because we also have privileged mode turned on. So we should be able to do all of our normal hardware-y type things that we're used to doing. And then we go into our child pipeline. Here's the non-Hill job, which just ran somewhere on a random cloud runner because it didn't need to be on there. So it's best practice, even if you're using Hill pipelines, don't run stuff on your Hill gateway that don't need to be run there, because it'll be more parallel and you're not wasting that precious shared resource. So all three have run. If we go back up to our upstream, we can see that the upstream ran fine. I'm going to click back at the pipeline level let me just go here so I can give a little bit of an explanation here. So with child pipelines, it can kind of be a little bit confusing, but what happened here was this ran in the main pipeline because of the component. So even though we don't see this, we see this code over in the component, and it was included and run simply because it detected that file. It then ran this test child pipeline, and if we click here, we can see all that ran in the child pipeline. If the child pipeline all runs successfully, then that bubbles up to this level, and then we go on to deallocate. And if I refresh my values here, we should see that this one is now again available. So it was on WCDX, variables reveal, and now they're all online and available. And then just real quickly, we're going to say run pipeline, and then we'll go back to pipelines again, run pipeline. We're going to get 3 going. Actually, maybe I'll try 4. Okay, so I started 4 pipelines, which means we should get all 3 of our runners allocated and a 4th one that's kind of in a waiting loop. So if I go here and refresh, all 3 of these are running. I'm going to refresh here. And if we go in here, we'll see that we're not getting out of Hill Allocate. If we dive into Hill Allocate, well, it's not quite up at end yet, but we'll see very quickly that it will start looping because there are no available runners. All of this is just controlled by querying all the variables in that project and looking for online and available. So you can do simple things like drain a runner by changing this to drain. And then when the project checks it, it's going to say, oh, it doesn't match. I'm not going to mess with it. And so then it'll leave off and you'll essentially have drained the runner. If you change it to something like offline in maintenance, then it'll never be allocated. You also potentially want to put helpful information in here like your user ID, your GitLab user handle, and then maybe a date so that if someone suspects that you forgot, you were working on something and you forgot, they know who to reach out to. So you can put helpful information in there. All right, we can see right here that for a period of time, we had to loop while there were no instances available in the pool based on the variables. Once that was resolved, we got an allocation and continued on with the job. And of course, it gives some helpful log information to show you which one it selected and what it put inside of it so that you can see that information. So that is the Hill Runner Pool in action. Once again, it is a solution built within GitLab. So there's no third-party software. One of the challenges is that this runner pool is also not blocked from someone simply using a tag. So you do have to follow some conventions so that you don't run into troubles. That's the basics of the Hill Runner Pool, and I hope it's helpful for you. Would love to have you create issues if you find any problems or issues or have ideas for enhancement. Where you would do that is when we go to I'm going to go back to the component. So here's the component in the catalog. You click on the source, and then you create a new issue within this project to let me know if something needs attention or you'd like some sort of new feature. Thanks very much for your time.